Hello everyone, very good morning and welcome to the BYJU'S exam prep. This is Sanjay Rathi and we are going to discuss what very important subject for ISRO examination, that is what microwave. Okay, and this is a ISRO 2023 on 17th of December with new pattern guys, and we will revise some important devices from microwave, and I am going to give you very important information, and that session will be very useful for you. Okay, so stay tuned with us, like the session and subscribe our channel. I think everything is fine now. Okay then guys, this is my introduction. Myself Sanjay Rathi, 23 years of teaching experience in the field of competitive exams like engineering services, GATE, ISRO, DRDO, BARC and all other competitive exams. And I have qualified and selected for engineering services exam. These are my ranks and I have trained more than 1 lakh students for these competitive exams. So Ankit, how are you? Very good morning everyone, and please join the session now and ask your friend to join. Now, this is my Telegram channel, that is Electronics by Sanjay Rathi, where I will upload the PDF of this session. Okay, just after the class. Then ISRO previous year question is enough. Guys, for microwave, if you are solving the ISRO previous year question, you will get around what? 10 to 20 questions only. 30 questions. But revise it quickly and you will get the basic idea about all the devices, and you will get around basic questions. Okay, so that is session for you. Okay, Altaf, Ravina, KR, very good morning. So this is my Telegram channel. Everyone please join that, Electronics by Sanjay Rathi. After 10 minutes I will share the link of this session, this Telegram channel, where I will upload the PDF of this session. Now these are our results, right? Again remember, microwave communication is important for what? Engineering services exam also. Microwave communication I am talking. So these are the result in engineering services exam, right? First rank, 9th rank, and number of students under 10, under 50 and under what? 100. And you can also start your journey with us. Okay, and that is a prestigious exam, national level exams. If you want to start your preparation, then start as early as possible. And anyone can crack this exam. But लेकिन minimum criteria तो होना ना, engineers हो और electronics, electrical, mechanical, civil and what. अगर आपकी ब्रांच अलग भी है तो भी आप इन 4 ब्रांच में से पेपर दे सकते हो थ्रू इंजीनियरिंग सर्विसेज एग्जाम गाइस. ओके, वेरी गुड मॉर्निंग रजनीश कुमार चौरसिया. Then watch this. First of all, I want to give you the brief idea about what are the syllabus, that is important topics, and get the basic idea about that. First of all, for example, introduction, what is microwave and what are the advantages and disadvantages and what are the applications of the microwave. Quickly I will explain. Then second important thing, microwave components guys. E-plane T, H-plane T, hybrid T, magic T, rat race junction, directional coupler. We are getting question from this, so I will give you the basic idea about that, and scattering parameter of all these devices. Then ferrite devices. Here we are using the ferrite that will follow the non-reciprocal property. Okay, so we are designing the isolator. So what is isolator? What are the application of isolator, gyrator and what? Circulator. Basic idea about that. Then we have number of amplifier and oscillator, because we can't use our conventional amplifiers, pentode, triode, right, in case of microwave frequencies. Then what are the limitation of those conventional devices? And that's why we have designed new devices for what? Microwave frequency range. That is the basic principle. What is the basic principle? Then 2 cavity klystron, multi cavity klystron, reflex klystron and so on. Then backward wave oscillator, traveling wave tube, magnetron, cyclotron. So these are the important devices here. Microwave, basic idea about that. What are the working principle? And then guys, solid state device like tunnel diode, MESFET, gun diode, transferred electron devices. And what is the example of transferred electron devices? Gun diode. So these are the solid state devices. Tunnel diode, you have the idea, where we are giving very high doping. Very high doping, that is 1 part in 10 raised to power 3. Okay, tell me what is the another name of tunnel diode, everyone. What is the another name of tunnel diode guys? Now here in gun diode I will explain the RWS theory, that is called Ridley-Watkins-Hillsum theory. Then we have one parametric amplifier. Then guys, avalanche transit time devices. Avalanche transit, okay, from this introduction you will be able to solve some questions. So that is important for you, that please watch this. So what is the avalanche means? What? Impact ionization. Transit time devices. So there are avalanche transit time devices, impact, Trappet and what? Barrett, and get the full form of this only. Again, they can ask what is the full form of that impact diode, Trappet diode and Barrett diode. Then guys, measure and laser. So microwave amplification by stimulated emission of radiation, and similarly laser light amplification by stimulated emission of radiation. Then microwave antenna guys, and that is the part of what microwave communication. In coming session I will cover this, but I am giving you the brief idea about that. Horn antenna, parabolic, slot antenna, lens antenna, helical antenna. Then microwave strip lines, microwave measurement, microwave communication, radar. Radar is also the part of what? Microwave. So this is the basic syllabus. Get the basic idea about all these topics guys. Yes, Ankit Kumar, tunnel diode, it is a highly doped PN junction. This is another name is what? Isaki diode. Yes, good. That is the right answer. Isaki diode. तो ये है माइक्रोवेव के important topics. Now that we are not going to get what 10 questions, because total questions are what 80. Mainly syllabus is based on syllabus of what GATE exam, but 1 or 2 questions from microwave or other subjects like what radar, microwave communication, okay, advanced electronics, but some basic question. So this is important subject for ISRO examination, because they are using what all these devices. Now, so we will start with this. Today we will try to cover all these topics. Introduction, microwave components, E-plane T, H-plane T, hybrid T, magic T, rat race junction, directional coupler, and what ferrite devices, isolator, gyrator, and what circulator. Okay, so stay tuned with me for next 1 hour. Quickly we will get the idea about all this. Then first of all, introduction. So everyone please like the session, and very good morning everyone. Amitabh Mohapatra, how are you? तो आप लोगों की ब्रांच क्या है जरा मेंशन कीजिएगा. होप ऑल आर फ्रॉम इलेक्ट्रॉनिक्स ब्रांच. ओके देन. नाउ introduction means what is the microwave frequency range? Means high frequency range, that is from 300 megahertz to what 300 gigahertz, and wavelength will be in the range of what micrometer. That's why it is basically called microwave. So that is the what is the relation? C is given by f lambda. So what is the lambda is equal to C by f. C is the velocity, that is 3 into 10 raised to power 8 meter per second, or 3 into 10 raised to power 8 10 centimeter per second. Lambda is called wavelength and f is called frequency. So we are getting the wavelength in terms of what microwave. That's why it is just we are saying that it is a microwave, right? Then frequency, that is the relation between the frequency and wavelength. Frequency is proportional to 1 by wavelength. Okay, so that is the case. Thank you. So Ankit, you are from electronics. Me, you are from electronics. Good. Now this is the introduction. Then what are the advantages of microwave? First question that may ask, because it is of high frequency, why we are using the high frequency? In communication we are getting the same. What are the advantages of what modulation? We are transferring the low frequencies into what high frequency. So what are the advantages of this, right? Then yes Arya, I will ask them to arrange one session on that antenna also, right? Complete revision session on antenna, microwave antenna. Then advantage of microwave, first of all, it increases the bandwidth availability. Bandwidth, the band of frequency for which the gain is almost independent of the frequency. So when we are using the high frequency, bandwidth will increase. First case, bandwidth will increase. Second advantage, improved the directive property. Directivity of the antenna will increase. Directivity of the antenna will increase, guys, right? So directivity, right, that is directly what when we are increasing the frequency, lambda will decrease. When the lambda will decrease, directivity will increase. Then fading effect and reliability, it will reduce the fading effect. Fading means weakening of the signal, we can say. because when we are talking about that is microwave communication, it works on what? Line of sight, LOS system, line of sight, right? And that's why the fading effect is very, very low, and that's why this system is highly reliable. Then very, very important property, that is called transparency property of microwave. Transparency property of microwave means what? Just watch this. Why the satellite communication is possible in case of microwave? Then watch this. Transparency property means, for example, this is Earth. Then here we are having the ionosphere. Guys, what is the frequency? If it is a normal frequency, then what will happen? If f is less than the critical frequency or maximum usable frequency, then ionospheric communication is possible. Ionospheric communication means when we are having the antenna here, we are sending the signal and it is refracted back and returned toward this antenna. This is called ionospheric communication. This is the ionosphere, and that ionospheric communication is possible. But if the frequency is greater than that maximum usable frequency, then what will happen? When we are giving the signal, it will penetrate it. This will penetrate this ionosphere and pass the ionosphere, and that is called transparency property of microwave, because its frequency is greater than maximum usable frequency, and because of that satellite communication is possible. Otherwise, if the frequency is less than, it is reflected back by the ionosphere, then satellite communication is not possible. So yes, it is the satellite communication is possible in case of microwave. At the end we are using the satellite. So that is called the transparency property of microwave. Now, most important one, size of the component is directly proportional to wavelength. Size of the component. If the wavelength is less, then what about the size of the component? Very, very less. So we can reduce the size of component if we are using the microwave frequency, guys. A smaller system is possible. This is another advantage. So they will ask 1, 2, 3, 4 which are the advantages of microwave. So that is the advantage. Now, next one, what are the application of the microwave, guys? Application of the microwave means we are using in telecommunication. Just mobile towers we are using the line of sight. Here we are using the microwave signal between one tower to other tower. Then intercontinental telephone and TV, space communication, telemetry communication link for railways. In radar we are using the microwave. Commercial and industrial application uses heating property of microwave. For example, microwave oven, we are using what? Microwave signals. Where we are using the magnetron. To watch the rating, at which frequency the microwave oven work. Please tell me, at which frequency microwave oven work. So here we are using the magnetron. Then drying machine and in public works, food processing industry we are using the microwave signal. Then biomedical application we are using the microwave signals. Electronic warfare we are using the microwave signal. Missiles and so on. Here we are using what? Microwave signals. So these are the advantages, applications of the microwave, guys. Okay, to get the idea, then guys, number of extra applications, so please go through it. That remote sensing, read this point. Gun diode oscillator, gun diode is a microwave devices, and waveguides are used as a motion detector for automatic door openers. This is the automatic door openers we are using. Remote sensing we are using the microwave radars. Microwave imaging we are using that signals. So these are the applications. Then for navigation we are using the microwave. Global navigation satellite system, global positioning system, we are using the microwave. तो आपको समझ में आया कि microwave signal why so important, and that why this subject is important. Okay then. Now guys, what are the range here? So this is about the microwave application of microwave, that is the microwave oven. passes the non-ionizing microwave radiation at a frequency near to what 2.45 gigahertz. So you have not given the answer. This is the 2.45 gigahertz, right? And that is the working of microwave oven. Here we are using magnetron. Magnetron is an oscillator that is we are using to generate the signal at microwave frequency. Okay. Then this is called band designation. Band designation, we are using the different designation. So L band according to IEEE, L band, S band, C band, X band, KU band, K band, K band and MM band. So these are the wavelengths. Then the frequency range from 1 to 2 gigahertz, that is the wavelength. What in centimeter, 30 to 15 centimeter. Frequency increases, wavelength decreases. Remember already I have given the wavelength is given by 3 into 10 raised to power 8 or 10, if it is in centimeter, 10 centimeter per second divided by f. You will put here and you will get the answer wavelength gigahertz. Giga means 1 gigahertz means what? 1 into 10 raised to power 9 hertz. You will get the frequency wavelength in what? Centimeter. So that is the band, L band, S band, C band, X band, KU band, K band, that is the frequency range. And finally, so there is a, in some books or in some, there is a slight difference, but almost the center frequency will remain same. For example, in some book it is given 1.2 to 2.4, but what is the center frequency near to 1.5, similarly that. So yes, revise this. And they will give you the band and they will give you the questions, guys. Okay. So you have to revise this. Then, next one, relation between the path traveled and phase change, because every device depends upon the wavelength. Size of the component depends upon the wavelength and function also depends upon the wavelength. There is a cancellation of signals, addition of the signal depends upon the phase change. So what is the relation between wavelength and phase change, guys? Simple. Wavelength and phase change means, this is a one important question here. This is the sinusoidal signal. Then this is the sinusoidal wave. So when the sinusoidal wave complete one cycle, so what is the change in the phase? 0, pi and what? 2 pi. Total phase change is 2 pi. This is omega t. And we are writing the signal as Vm sin omega t. Vm sin omega t. So what is the phase change? 2 pi. And the time taken is t. Time taken is what? T. Now what is the path traveled actually? The path traveled during one cycle is lambda. Path traveled during one cycle is called what? Lambda. Then what will be the velocity? Velocity of wave, that is given by what? Lambda by t. Right? Lambda t. And what is the 1 by t? This is called frequency. So in one time period it will cover one cycle. So that is 1 by t is called frequency, and that's why velocity is called f lambda. Velocity is called what? F lambda. Lambda is the wavelength, that is the path traveled during one cycle, and then frequency f lambda, that will become velocity. Now what is the relation between the phase change and path traveled? When it will travel the lambda path. This is the path traveled. This is very important question also. And what is the phase change? Phase change, that is phi. Path travel is lambda, then phase change is 2 pi. Path travel is half, lambda by 2. What is the phase change? Pi. When the path travel is lambda by 4, this is the lambda by 4. So what is the phase change? Pi by 2. If the path traveled is L, what is the phase change? Then the phase change is given by 2 pi by lambda into L. 2 pi by lambda into L. L is the path traveled and that is the total change in the phase. This is an important formula, guys. Path traveled and phase change. Okay. So that is yes, beta. So that is the beta is what? 2 pi by lambda. In EMFT we are using 2 pi by lambda. Then guys, what is the limitation that we are having three parameters, because in every two-port network we want to explain. Suppose we are having the two-port network V2, I2, V1, I1. What we are using? Two-port network. To just explain this two-port network, we are using what? Z parameter, Y parameter, and what? H parameter. Right? So then you can get this idea. I think I have not having the right range, but that military we are using the different range for that. In case of satellite communication, again we are using the different range, and for commercial we are using the different range, and for satellite we are using the different range, guys. Okay, and for military again we are using the separate range for that. So you can, I will provide you the data on my Telegram channel, right? Okay, then this is the two-port network. Two-port network we are explaining by what? Z parameter, Y parameter, and what? H parameter. Z, Y, and H parameter. Then what is the Z parameter? These are called open circuit parameter. Y parameter, these are called short circuit parameter. H parameter is called hybrid parameters. But we can't use these parameter at a high frequency or at microwave frequencies, guys. So you can't explain the network in high frequency by using these parameters, because it is very practically very difficult to make the circuit open circuit or short circuit at high frequency. Because to calculate the Z parameter, Y and H parameter, we have to make the terminal open or short. But once we are making the terminal open or short at high frequency, the system become unstable, right? That is the problem, and it is really not possible. We can't read the, we are not having the instrument to read all these parameter at a high frequency, guys. Okay, so that's why Z, Y, and H parameter is not preferable at high frequency. So we are using what? S parameter. We are using S parameter at a high frequency. S parameter is called scattering parameter, guys. So this is the scattering parameter or scattering matrix here. So this is the four parameters. Here it is a signal A1, A2. These are the incoming signal A1, A2. What are the outgoing signals? B1, and at the input, the outputs at B2, right? So these are the signals. It may be voltage or it may be current. It doesn't matter. It may be voltage or it may be current, but we are talking in terms of what? Power. Input power, reflected power, output power, reflected power from the ZL, because when there is no proper matching, there will be the reflection from the load. In EMFT, you are asking that reflected power. We have the reflection coefficient. Okay, so that is similarly, it is the incident power, then it is a reflected power. It is the input power, then it is a reflected power, and so on. So we are having the four parameters. So that is given. B1 is equal to S11A1 plus S12A2. And what is the B2 is equal to S21A1 plus S22A2. So these are called scattering parameters. These are called what? Scattering parameters, guys. So you can explain just, for example, I can give the, what is the S11? S11 is given by B1 upon A1 with what? A2 is equal to 0. Similarly, you can explain the S12 is equal to B1 upon A2 with A1 is equal to 0. S21 B2 upon A1 with A2 is equal to 0. And finally S22 B2 upon A2 with A1 is equal to what? 0. These are called scattering parameters, guys. Okay. Then this is the, already I have explained the conditions. Then what are the properties of the scattering parameter? So what are the properties? First property, it is a square matrix of size n cross n, where n is the number of ports. So now in two-port network, we are having the two-port only. So what are the two-port here? This is the two-port, port 1 and port 2. So we are having the, what about the scattering matrix? So we are having the scattering matrix like what? 2 by 2. S11, S12, S21 and S22. But we are also having the three-port devices. For example, circulator. Circulator is a three-port device. Circulator is a three-port device, guys. So when the circulator is a three-port device like this, so we are having This is the circulator. Now, so if it is a circulator, then it is a 3-port device. So what is the size of the matrix? 3 cross 3. S11, S12, S13. S21, S22, S33. S23. S31, S32, S33. What is the size? 3 cross 3. It is a square matrix of size n cross n, where n is the number of port. This is the port number 1, this is the port number 2, this is the port number 3. Then next property is principal diagonal elements represent reflection coefficient of the respective ports. What is the principal diagonal elements? For example, if it is a 4 cross 4 matrix, so these elements S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. This is called, this is the diagonal, this one is the diagonal. 1 minute. This is the diagonal elements. This is also a diagonal elements, but this is called principal diagonal elements. Means S11, S22, S33 and S44. This also represent the reflection coefficient of the respective ports. So what is the meaning of the reflection coefficient of the respective ports? Means this is the port 1. So S11 represent the reflection coefficient for this. S22 represent the reflection coefficient for this. If we are having the 4-port device, then S33 will represent the reflection coefficient of this, and so on. So that is called reflection coefficient. So they will give you the matrix. If that diagonal elements are 0, 0, means what? That particular port is perfectly matched. We are giving the power, but there is no reflected power. Means that particular port is perfectly matched, guys. Okay, that word is used. So simply, if the S matrix is given, go through the diagonal elements and watch which element is 0 and which is present. If it is non-zero element, means there is a reflection coefficient, and you can also find a standing wave ratio, SWR. Okay, SWR you can find. Now, so that is the properties of the S matrix. Next property of the S matrix is, then this is the principal diagonal elements. It is a unitary matrix. So we are getting question on this. This is the part of matrix mathematics. Again, you will get the similar type of question. It is a unitary matrix. Means when we are multiplying the S matrix with its complex conjugate term, means S parameters are also what? Real number, or it may be what? Complex numbers. Remember, it may be real number or it may be what? Complex. X plus JY. This is complex. It may be real, it may be imaginary, or it may be complex. So it is a unitary matrix. Means when we are multiplying the two matrix S and its complex conjugate, you will get I. And what is the I? Means unitary matrix. Means this one, 1, 0, 0, 1. This is called unitary matrix. Now, it is a symmetrical matrix for reciprocal network only. If any particular network is reciprocal, then reciprocal means when we are changing the direction of input and output, we are getting the same response. Then that network is called what? Reciprocal network. In that case, it is have the symmetrical matrix. Symmetrical matrix means simple S12 is equal to what? S21, or S32 is equal to S23, and so on. If that condition is satisfied, then it is called symmetrical matrix, guys. Okay, then so these are the property. Next property, zero property. Zero property means it states that by this is a scattering matrix. It is important for what? Microwave, but it is a part of what? EMFT, electromagnetic field theory. So someone says, sir, microwave, we have less number of questions, but it is a part of what? EMFT also. तो यहाँ तो गेट में भी क्वेश्चन आएगा. तो जीरो प्रॉपर्टी, it states that sum of product of each term of any row or column multiplied by the complex conjugate of any other row is 0. So suppose you are having the matrix S11, S12, S13, S21, S22, S23, S31, S32, S33. If you are going to multiply this row R1 and this is the R2 and this is the R3. When we are multiplying S11 and what is written here, complex conjugate, multiply complex conjugate of any other row or element, S12, S21 complex plus S12, S22 complex conjugate plus S13, S23 complex conjugate, and it will be what? 0. That is called 0 property. Similarly, you can multiply this column with this complex conjugate of this. Complex conjugate of this, and you will get the S11, S12 complex, S21, S22 complex, S31, S32 complex conjugate, and you will get the 0. And that is called what? 0 property. Then, if any one of the port or reference plane are moved away from the junction by an electronic distance beta L, that is the beta 2 pi by lambda, right? Then each of the coefficient of S matrix related to that particular port will be multiplied by the factor of e raised to power minus j beta L. Means what? If simply this is the port, sometimes just that is the reference, that this is the reference, but we are increasing the length, and this length is what? Beta L. Length is L, and what is the change in the phase? 2 pi by lambda into L. So we are not giving signal at this point, we are giving signal at this point. Means we are moving from the reference point by this distance. Then there is a change in the phase. Then what we have to do? Every S parameter related to that particular port. For example, it is port 1. So S11 is related to that, S21 is related to that, S31 is related to that, S13 is related to that. So we are having the 1 there, we have to multiply it what? E raised to power minus j beta L. E raised to power minus j beta L. Each of the coefficient of S matrix related to that particular port will be multiplied by a factor e raised to power minus j beta L. So you will get the new S parametrics when we are shifting the reference plane. Okay, reference point also. So this is the case. These are the property of S matrix. Now guys, once you have the idea that why we can't use the Z parameter, Y parameter and H parameter at high frequency, at microwave frequency, and we are using what? Scattering parameters. Okay. Now, scattering parameters, already we have idea about the properties and what is the scattering parameter. Now, different types of devices. The first device is what? Junctions. Go, simple set. We have to add the signals or subtract the signals. We want to increase the power, we want to split the power, right? We are getting the input power, we want to decrease in, we want to divide it into 2 parts. We have to use what? Different types of devices. So those are called what? Junctions. T. So we are having the T. This is the, actually this is the T shape. That's why it is called T. Now, first is what? H plane T. So what is the H plane T? As you know, the electromagnetic wave means there are 2 fields. One is what? Electric field. One is what? Magnetic fields. They are perpendicular to each other. Electromagnetic field. That is, they are perpendicular to each other. And according to Poynting's equation, right? Poynting theorem. What is the power? E cross H. You have the idea that power depends upon E as well as H. Means electric field as well as magnetic field. Now, when we want to divide the power, we are having the 2 possibilities. First is what? Electric field will remain same. We can divide the magnetic field into 2 parts. H by 2, automatically the power is divided into half. Or keep magnetic field constant, you can divide what? Electric field. Then again the power is divided because power is proportional to E cross H, cross product. Then similarly, in H plane T, this is the H plane T, watch this. This is the port 1 and port 2, this is the port 3. So port 1 and port 2 are called collinear arm, port 3 is called H arm. When we are giving the power at this point, this is divided into 2 parts, P by 2, P by 2. So it is called 3 dB splitter. This is called 3 dB splitter because that power is divided into P by 2, P by 2. So what is the 10 log of P upon P by 2? You will calculate. So 10 log of 2, that is nothing but 3 dB. And that's why it is called 3 dB splitter. Power just half divided. Now, In case of H arm, actually we are dividing the magnetic field. Or magnetic field is proportional to what? Current. Means we are dividing the current, and current is divided into what? Current divided when there are connection in what? Series. Parallel in network. For example, if you want to divide the current, then two paths are connected in parallel. We are giving the current. Current is divided into two parts, I1 and I2. Right, and this, if these resistors are equal, then it will become I by 2, I by 2. So when we want to divide H, and H field is what? Directly proportional to current. It means we want to divide the current. Means what? Shunt junction. So this is also called shunt junction. So magnetic line divided, current divided, means that's why H plane T is also known as shunt junction. That may be the question. Shunt junction. Okay. Similarly, when we are giving the signal at this port, at port 3, the output is coming out from port 1 and port 2. They will be in same phase. They will be in same phase. There is no change in the phase. We are getting output from 1, we are getting output from 2, and both will be in the same phase. So these are the property of H plane T. And when we are giving the power, nothing will come out of the port 3. And that's why it is perfectly matched. That's why it is perfectly matched. Then, so what is the important? What is the S parameter matrix of the H plane T? So you have to revise, because it is not time to derive. Otherwise I can derive, but it will take time, because it is a quick revision, guys. First of all, remember, port 3 is perfectly matched. That's why S33 is 0. Right? First thing, you can directly say S33 is 0. Second, you can write, when we are giving the power, it is divided into two equal halves. It is P by 2, it is P by 2. And they all are in same phase. So this is the port 1, this is the port 2, this is the port 3. So what is the relation between when we are giving the input and when we are getting the output? So what is the relation between S13 and S31? Because it is reciprocal also. And remember, when we are calculating the S parameter, actually it is not the power, it is the ratio of what? Voltage or current. And what is the relation between power? Power, normalized power is proportional to I square, or normalized power is proportional to what? V square. So that's why if you want to find a relation between 1 and 3, then it is actually root over P by 2 upon P. Current or voltage, that's why it will become 1 by root 2. 1 by root 2. Positive sign. Why positive? Because when we are giving input, they are in same phase, they are in same phase. So S13 and S31 is 1 by root 2. Similarly, S32 is equal to S23. 1 by 2. 1 by root 2, 1 by root 2. So you can say this is the value. Now, 1 by 2, 1 by 2 and minus 1 by 2, minus 1 by 2. These parameters we are getting by the property of S matrix. What are the property of S matrix? Unitary matrix. Right? It should satisfy the, this is the S complex. Is what? 1. Second, when the row of 1 is multiplied with the complex conjugate of the other row, you are getting the 0. That is called 0 property. So from this we are getting all the S parameters. It is a 3 by 3 matrix, because there are 3 ports. It is a square matrix. S33 is equal to 0. It is because it is perfectly matched. And 1 by 2, 1 by 2, minus 1 by 2, minus 1 by 2. You have to revise this formula. This is the S matrix, and they can give what? Match the following type question, and there are 4 options which represent the S matrix of H plane T. And what is the another name of H plane T? That is also called shunt junction. Now, I think now it is over. Now, if you want to get the idea about the E plane T, then what is the conclusion? This is the port 3 is perfectly matched. It is called 3 dB splitter because the power is divided into P by 2, P by 2. Output from port 1 and 2 are in the same phase if the input is given to port 3 only. We are getting the output in the same phase, guys. Then E plane T. Just E plane T means what? We are giving the power here. Again, that is divided into 2 parts. P by 2, P by 2. But this time they are not in the same phase. They are in opposite phase. So when we are giving the power P, this signal and this signal are in the same phase. But at this point we are getting opposite phase. But that's because of that we are getting the negative relation between these two. So this is the port 3, this is the port 1. So what is the S13 is equal to S31? It is, we are getting the 1 by root 2 positive value, because it is a power is divided into half. But S23 is equal to S32, S13 is equal to S31, you will get minus 1 by root 2. Why minus? Because there is a 180-degree phase shift between these two. Opposite phase we are getting. Second thing, here the electric field is divided. Electric field means what? Voltage divided, and voltage divided into, in what? Series connection. Voltage divided in series. When the two resistors are connected in series, we are having the power 10 volt. If both the resistors are equal, so what is the voltage between each resistor? 5 volt, 5 volt. So that is divided in series. So electric field means voltage divided, voltage divided in series. That's why it is also known as series junction. E plane T is also known as a series junction. Okay. These 1 and 2 are called collinear ports, guys. Port 3 is perfectly matched because when we are giving the power, there is no reflected power. And that's why what is the S33? 0. So you will get the S matrix like this. This is minus here. This is the nothing but S32 and this is S23. This is S13, S31. These are positive value. And remaining we are getting from the property 1 by 2, 1 by 2, 1 by 2, 1 by 2. Unitary matrix as well as 0 property we are getting. So this is the S matrix of E plane T. So they will ask, then match the following and you can get the answer. H E plane T. So if you are enjoying the session, then guys simply like the session. यार enjoy क्या करना, important subject है. अगर कोई enjoy करके पढ़ता है इसका मतलब वो एग्जाम को साइड इफेक्ट में निकालेगा और तभी तो आप अच्छे साइंटिस्ट बनोगे. और अगर इंटरेस्ट नहीं है तो भाई देखो बन तो जाओगे लेकिन बड़ी मुश्किल से जिंदगी कटेगी आपकी, याद रखिएगा. ठीक है ना. साइंटिस्ट बनना है मतलब क्या करना पड़ेगा, आपको इंटरेस्ट से काम करना होगा. यस, पढ़ाई करना आसान है क्या, और साइंटिस्ट जो है उसको तो हमेशा ही पढ़ते रहना है. आपका ऐसा नहीं है ना कि एक बार नौकरी लग गई और टेक्निकल नॉलेज जितना है उसी का यूज करके मैनेजरियल स्किल या एडमिनिस्ट्रेटिव जॉब में जा रहे हो. इफ यू वांट टू एंटर इनटू द इसरो मींस आप समझ लीजिए कि आपको लाइफ टाइम आपको पढ़ना है. तो यस, इंटरेस्ट दिखाइए आप लोग. ई प्लेन टी अभी तो ये बेसिक है, इसको बहुत डिटेल में आपको पढ़ना होगा वहां पे. जस्ट गेट द बेसिक आइडिया. देखो अब ई प्लेन टी और एच प्लेन टी में क्या खास, व्हाट इज द स्पेशल प्रॉपर्टी. ई प्लेन टी पोर्ट 3 is perfectly matched. Port 3 is perfectly matched, but what about the port 1 and port 2? Port 1 and port 2 are not perfectly matched because S11 is half, S22 is also half, means it is not perfectly matched because it is the reflection coefficient of port 1, it is the reflection coefficient of port 2. What is the reflection coefficient of port 3? It is 0. Perfectly matched means when we are giving the power, there is no reflected power. So only the port 3 is perfectly matched. 1 and 2 are not perfectly matched. Okay. Similarly in H plane T, that is not perfectly matched. Watch this. 1 by 2, 1 by 2. So only port 3 is perfectly matched. Then we want all the ports should be perfectly matched. Then what will happen? We are designing a circuit that is called what? Magic T. So magic T or hybrid T, or it is also known as E plane H plane T. So here we are just connecting what? E plane T and H plane T. So there are 4 port devices. This is called H arm port 3 and this is called E arm port 4. So this is a magic T, guys. Magic T means, what is the magic in magic T? What is the magic in magic T? Magic in magic T is what? Magic in magic T is simply that we have all the 4 ports perfectly matched, guys. Okay, so all the 4 ports are perfectly matched. Then what we can do? First of all, S11, S22, S33, S44, all are perfectly matched. That is the magic in magic T. Okay. Now, second thing, when we are giving the power to third arm, we are getting output from port 1 P by 2, output from port, this is the P by 2. But what is the power output from H arm? 0, because it is a perfectly matched. But at the same time, what is the power output from the port 4? 0. Similarly, when we are giving input to port 4, P dash, we are getting P dash by 2 here, P dash by 2 here. No doubt, there it is perfectly matched. There is no reflected power. But at the same time, what is the power from the port 3? 0. Means when we are giving the power to port 3, that is H arm, we are getting output from 1 and 2. At the same time, when we are giving the power to port 4, we are getting output from 1 and 2, nothing from the 3. Means 3 and 4. H plane T, H plane arm, E plane arm are isolated. Isolated means when we are giving the power this, we are not getting nothing from this. When we are giving power to this, we are getting nothing from this. So this port 3 and port 4 are isolated port. For any isolated port, the matrix will become 0. When any isolated port, then matrix will become 0, guys. So this, in this way we can draw the S matrix. This is, so normally it is represented like this. This is a straight line, and that is called, this is the E plane T, E arm, port 1, port 2, and that is H arm. Okay, so that is represented by this lines. And remember, all the 4 ports are perfectly matched, and that's why the diagonal elements are 0. All the diagonal elements are 0. And second thing, already I have given S34 is equal to S43 is also 0, as well as these ports 1 and 2 and 2 and 1. When we are giving something to 1, because of that property, symmetrical matrix, when we are giving the power to 1, half power here, half power here. So what is coming from the 2? Nothing. Similarly, when we are giving the power, because it is a symmetrical matrix, it will follow the reciprocity. P by 2 here, P by 2 here. So what is the output from the 1? 0. So what is the S12 and S21? These are also isolated. These are also isolated. Okay. So that is the S matrix, guys. Watch this. All the diagonal elements are 0. 1, 2, 3, 4. S34, S43 is equal to 0. S13 is equal to S31 is equal to 0. Now what about the remaining? So remaining you can quickly write, guys, what is the relation between the E and 1 and 2. This is the 4th port. So when we are giving the power here, we are getting the power P by 2 here, P by 2 here. But what about the phase? That is the arrow represented, the phase. Here that will be in the same phase, here it will be in opposite phase. So this is the phase. P by 2, P by 2. And that's why, what is the S14 is equal to S41 is equal to what? 1 by root 2. They are in same phase. Power become half, that's the matrix will become 1 by root 2. But what is the S24 is equal to S24, S42? It will become minus 1 by 2. Minus 1 by root 2. Why minus 1 by root 2? Because it is in opposite phase. Now you can write this. This is the S24. S42. This is what? S24. Similarly, this is the S14. S41. This is S14. Get the value. Okay. For H arm, if you are giving the power, here you will get the P by 2, here you will get the P by 2. Remember, this is the 3, this is the 2, this is 1. So we are getting in the same phase. All are in same phase. So what is the relation between S31? S13 is equal to S31 is equal to plus 1 by root 2. Similarly, what is the S23 is equal to S32 is equal to what? Plus 1 by root 2. All are positive because it is H arm. H arm. Now, you can give all the parameters. No need to mug up, guys. No need to mug up. This is the S matrix for what? Magic T. And what is the magic in magic T? All the diagonal elements are 0. means all 4 ports are perfectly matched. And these all are what? Reciprocal devices. These all are reciprocal devices, guys. Reciprocal devices means S12 is equal to S21, S32 is equal to S23 and so on. This is a reciprocal devices. So E plane T, H plane T, magic T. If hope you have enjoyed this. Yes. Now next thing. Next one. So tell me this type of questions. The magic T is commonly used in mixing, duplexing and impedance measurement. These are all the applications are measured. Why? What is the use of the magic T in mixing? When we want to mix the signal, we are using the magic T. When we want to duplexer, duplexer means an antenna which is used as what? Receiver as well as transmitter. So we can use the magic T as a antenna also, duplexer 1 and 2. So I will give you the idea that how we are going to make a duplexer. So it is used as a duplexer, transmitting antenna as well as what? Receiving antenna. Then impedance measurement at microwave frequency, we are using the magic T. So these are the application of the magic T. It is characterized by a S matrix given S. So where we are having the 0 0 and that in this way you can characterize by the magic T. So when which one is the correct? Tell me. Which one is correct? This is not correct because S12 and S21 are 0 0. They are isolated port. S12 collinear ports are isolated port. Wrong. Again this is wrong. Now these two. It is all the diagonal elements should be equal to 0, but here the diagonal elements are not 0. That is correct. This is wrong. C is the answer for this particular question. Okay. So this is the question. Next one. बताओ भाई क्या होगा? Answer is C, correct. अब आते हैं दूसरा. तो okay. Now next one. This type of question. Consider the following statement in case of a magic T. The collinear arms are, they will give you the 1, 2, 3, 4 and out of this which is wrong, which is correct. The collinear arms are isolated from each other. Collinear arms means 1 and 2. 1 and 2 are isolated from each other. Tell me this statement right or wrong. One of the collinear arm is isolated from the E arm. One of the collinear arm is isolated from the H arm. E and H arm are isolated from each other. So which statements are correct? Why? If we are giving power to E, we are getting the output from 1 and 2. So no one is isolated from the E arm. Similarly, when we are giving the H, we are getting the power from this, power from this. Means they are not isolated from H arm. But E and H arm are isolated and 1 and 2 are isolated. So statement 1 and 4. E and H arm are isolated as well as 1 and 2 collinear ports are isolated. Okay, so that is the case. So similar type of statement, that is the question. Then in a microwave magic T, E plane and H plane are, very simple question, MCQ. E and H arm are in phase, out of phase, 90 degree out of phase, isolated. We are not getting any output when we are giving input. So these are called ISO. This type of questions you can assume, right? And then that is what another on matrix, which of the following relation would be true of the magic T shown in the given figure. Now remember, in this diagram, what is the change? The port 3 is taken as E arm and port 4 is taken as H arm. So we are just changing the subscript, guys. That is a very, very important, and that's why I have chosen this question. Port 3 as a E arm, port 4 as a H arm. But 3 and 4, it doesn't matter. What is the property of E arm and H arm? It is important. So guys, S13 positive, we are giving the power. S13 is equal to what? S31 positive value. So, and S23 is equal to S32 will become minus 1 by root 2. That is what? 1 by root 2. Now S14 is equal to S41 is equal to 1 by root 2. S24 is equal to S42 is equal to what? 1 by root 2. And what is the S34? is equal to S43 is equal to 0 because it is isolated port. S12 is equal to S21 is equal to 0 because it is isolated port. And all the diagonal elements are 0 because all are perfectly matched. So that is the relation you have to find. Now S13 is equal to S23. S13, what is the S13 here? S13 is equal to 1 by root 2. And what is the S23 here? S23, no, this is negative. S23 is not equal. Watch this, it is negative, it is positive. Wrong. S14 is equal to S24. S14 is 1 by root 2. S24 is also 1 by root 2, means this is correct. S12 is 0. Yes, S12 is 0 because these are isolated port. S34 is 0. Yes, this is also isolated port. 2 and 3, 2, 3, 4. 2, 3, 4 is the correct answer. I think now you got the idea about the magic T, because magic T is a very, very important device, guys. Now, next one. Magic T is a important device. So before entering into the next, the complete roadmap to be a topper in GATE 2025, guys. Important workshop by Abhinav Negi sir on 6th of December, Wednesday, 7:30 p.m. If you have any queries related to GATE exam 2025, ask your junior to join this and ask your questions, attend this. For this, you have to register. Then before that, install BYJU'S exam prep app from Google Play Store. Okay, रजिस्टर करो और अपनी जर्नी हमारे साथ स्टार्ट करो. ऑल फैकल्टीज आर हाईली क्वालिफाइड एंड एक्सपीरियंस. ओके, और आप अगर देखो गेट 2025 के लिए प्रिपरेशन स्टार्ट करना चाहते हैं तो जितनी जल्दी हो सके कीजिए, बिकॉज इट इज अ नेशनल लेवल एग्जाम्स. इफ यू आर इन थर्ड ईयर, अगेन यू कैन गिव, राइट, एंड चेक योर एलिजिबिलिटी फॉर गेट 2025 and start your preparation with us. Then now this is an important question. Try to solve this question. This is homework for you. I will give you the detailed answer on my Telegram channel. It is a very, very, very interesting because we are connecting two magic T here and we are giving the power at particular port and what we are getting output from the other port, guys. These are the options. These are the options, guys. Okay. Then try to solve this question. Everyone, try to solve this question. So second important device is what? Directional coupler. Directional coupler. Number of questions on directional coupler in ISRO exam. So that is, in a directional coupler, actually we are having the two waveguides connected parallel. They are internally connected, first and second. Then this is called primary and secondary waveguide. One is called primary waveguide, one is called secondary waveguide. Now here when we are giving the signal, this is called incident power. Here it is called received power. Incident power, this is called received power. Port 1, port 2. Then port 3, we are coupling some power from incident power toward that port 4 here. And that power is called forward power. And we are measuring this forward power here. At the same time, we have some reflected power that is called what? Back power. So there are 4 ports, port 1, port 2, port 3, port 4. 1 received power, input power, incident power, port 2 received power, port 3 that is called back power, and port 4 is called forward power, that is called directional coupler. Now there is a relation between what? All these 4 ports. So this is actually device. This is the directional coupler, guys. This is a directional coupler. It is a 4-port device, directional coupler. Then first factor is what? Coupling factor. Actually, what you want to couple the signal between the 2 ports. You want to couple this signal here. So what is the coupling factor? That is the relation between Pi and Pf. This is given by 10 log of Pi upon Pf. So what is the value? Normally it is a 20 dB. So we want to couple the power that is given by forward power is given by P by 100. If it is 20 dB, P by 100. Means if it is a 1 milliwatt, so what is the coupled power, forward power here? 1 by 100. 1 by 100 milliwatt. Now, this is called coupling factor. Second called directivity. Actually, we want to couple the power between what? Port 1 and forward power path. But what should be the back power? It should be 0. back power should be equal to 0, but there will be a back power. So what is the directivity actually? We want to direct the signal here. We want to direct the signal here. So what is the wanted here? Signal 0. Back power ideally it should be 0. But we are having some leakage and some problem with the device. So we are having the non-zero value of PB. So what is the relation between PF and PB? That is called directivity. So 10 log of PF by PB, it is called directivity. And ideally the PB should be 0, directivity should be infinite. Normally the D is what, 60 dB, means the back power is 1 by 10 to the power 6 times of forward power. This is the normal value. Third one is what? Isolation factor. This port should be isolated. So what is the relation between incident power and PB is called isolation factor. 10 log of Pi upon PB. Ideally PB 0, I should be infinite. Otherwise practically it is given by 10 log of Pi upon Pf into Pf upon Pb. This is called what? This is called coupling factor, and that is called directivity. So what is the isolation factor? Coupling plus directivity. So normally I is what? 60 directivity, 20 coupling factor. So isolation factor is 80 dB. Isolation factor is 80 dB, typical values of this. So remember these three factors: isolation factor, coupling factor and directivity, related to directional coupler. Directional coupler, guys. Now, so we are normally using the two-hole directional coupler. So this is the two-hole directional coupler. So what they will ask, what is the gap between the two hole? So this is we are having the primary waveguide, secondary waveguide. We are creating a hole between these two, and because of that we are giving the incident power, we are getting the forward power here, back power here, and so on, and received power there. Then what should be the gap between the two hole for proper functioning of the circuit? That is given by odd multiple of lambda g by 4. So this is the question. Odd multiple means this is 2n plus 1. This is called odd multiple of lambda g by 4. Where lambda g is the wavelength inside the waveguide. That is called guided wavelength. That is called what? Guided wavelength. So that will be the question. What is the difference between the two hole? 2n plus 1 lambda g by 4. That is what? Odd multiple of lambda g by 4. Next question. What is the S matrix of the directional coupler? So you will get the S matrix of directional coupler like this under ideal condition. Under ideal condition, when PB is 0, that is the back power is 0, means 1 and 3 are isolated. When we are writing, that is the matrix. That is the matrix, guys. So 0, P, 0, JQ, P, 0, JQ, 0, 0, JQ, 0, P, and JQ, 0, P, 0, guys. And that is the factor. So please, you have to revise it because it is now time to derive it. Otherwise, I can derive it. But remember, that is the important formula. And when the particular port is isolated, you will get what? That is equal to what? 0 factor. 0. S13 is equal to S310. S23 is equal to S240. Because it is also a symmetrical device. Symmetrical device means we can change the port. Right? Incident port is used as reflected port. Reflected port is used as incident port. So this is a very important question on directional coupler. The important points. Coupling factor is measure of how much of the incident power is being sampled, while directivity is measure of how well the directional coupler distinguishes between the forward and reverse traveling power. That will give the relation between PF and PB. Okay. Now tell me, which device can detect the presence of both forward and backward waves in the waveguide? Both. Forward wave measure, backward wave it can measure. Tell me, which device? Forward as well as backward wave. Directional coupler. If suppose it is a forward wave, so it is measured here. It will couple, and here we can use the measuring devices. It can measure here. Right? If there is a backward wave, reflected wave, then this is used as what? Incident. That is used as coupling because it is a symmetrical device. Now it will become incident power. This will become back power. This will become what? a received power, and that will become what? Forward power. Here you can use the measuring device and you can measure the back power, reflected power. So at this time, this is the incident, this is the received, this is the back, and this is what? Forward. It can measure the forward power, it can measure the reflected power. So both we can measure. That is what? Directional coupler. C. This is the directional coupler. What is this? Is the, that is sometimes 4-port microwave passive device has the scattering matrix. Watch this. All the 4 ports are perfectly matched. Means this is a magic. It is a symmetrical device. It is a reciprocal device. So we are having this P and so on. Now watch this. This is a matrix of what? Directional coupler. Matrix of directional coupler, guys. D is the answer for this question. So straightforward, you can give the question answer for this, all these questions. Okay, then now try to solve this type of question, and that is the question in what? ISRO examination. Try to solve. I will give the solution in my Telegram channel, but first of all, you are getting which type of questions they will ask, sir, in ISRO. So that is the question from the directional coupler. A 4-port directional coupler has 4:1 power splitting ratio, has a dissipation loss of 3 dB. The coupler directivity is what? 40 dB. Directivity is given. What fraction of the input power P1 will go to the port P2 and P3? Watch this. This time name is changed. 1 is the incident power, 2 is the received power, 3 is the coupled power, and 4 is the isolated port. So everything is given. 4-port directional coupler. 3 dB loss means what? When the signal travels from this is called the path loss. And then the coupler directivity is 40 dB. D is given. Directivity. So 20 log of PF by PB. It is given directivity. That is the 40 dB. Okay. And coupler directivity. What fraction of input power will go to the coupling factor is different thing. Coupling factor is 20 log of incident power upon what? Forward power. This is the forward power. That is the question. Try to solve this type of question. That is in what? ISRO examination. Okay. Previous year question. I will give the answer, but first of all, try to solve this. Now, so first of all, as I said, sometimes they will ask what is the coupling factor in dB. So coupling factor means what? Relation between incident power and what? This diagonal forward power, P1 and P4. So what is the P1 and P4? This is the first A option, coupling factor. Coupling factor is P1 and P4. And P1 and P3, this is called back power. This is called isolation factor. P1 and P3 is called isolation factor, and P3 and P4 is called directivity. This is the coupling factor. This is what? Isolation factor. Put the 10 log of that. 10 log of that. Okay. This type of questions they will ask. That is on the directional coupler. I think you got the basic idea about that. Okay then. Now, just I want to give the idea about what isolation ferrite devices. Before starting the ferrite devices, just within 10 minutes you will get the idea about the ferrite devices. Then if you are interested, then write me comments on comments box. If you want more detail about all the devices, then I will ask them to arrange one extra session for that, guys. Okay, that where in part 2 I will cover the basic idea about all the tubes, guys. All the tubes means klystron, reflex klystron, backward wave oscillators, and what TWT, impact trapet, Barrett, right? Gun diode. What is the basic principle? Quickly within 1 hour we can cover. So before that, it is a EC branch mega mock test, all India open mega mock test for GATE 2024 from 16th of December to 22nd of December. And register now for this, guys. You can register here for this. But before that, install the BYJU'S exam prep app now. I think you have installed. No, then please install now and join my Telegram channel also. That is Electronics by Sanjay Rathi. I will upload the PDF. Now we will discuss what another devices. That is called what? This is again homework. Try to solve this question. Now, what is the Ferrite devices. Remember, first question is what? Ferrite is a non-reciprocal device. Ferrite is what? A non-reciprocal device, material. When we are designing the circuit by using the ferrite, we are getting non-reciprocal devices. And example of the ferrite devices is, first is isolator, then gyrator, and then what? Circulator. It is depends upon the principle of Faraday's rotation in ferrite. Faraday's rotation in ferrite, that is the principle of ferrite devices. Then first one is isolator. Isolator means it is a two-port device. It is a two-port device. Now, when we are giving the signal in this direction, it will allow the signal least minimum attenuation or zero attenuation, ideally minimum attenuation. It will pass the signal. But in opposite direction, it will block the signal. Maximum attenuation. Maximum attenuation. So that is the isolator. Isolator. We are using isolator to isolate generator and what? Load. So for example, if this is the generator is connected, this is the load is connected, and directly when we are connecting, to generator will send, this is the generator and that is the load. Generator will send the power. If it is not perfectly matched, it will give the back power, reflected power. This is the input power and that is the reflected power. And because of that reflection, what will happen? It will affect the frequency of oscillation, right? Because of this power, reflected power, the frequency of this will change and maximum power output is also affected. The change in frequency is undesirable. That's why if you want to make the frequency of generator stable, what we are doing, in between them we are using isolator. For example, it is generator, it is load, in between we are using the isolator. So isolator, what will happen? It will allow the signal in one direction. When the generator want to send, it will send the signal. But in opposite direction, it will stop. It will not pass the signal in this direction. It will stop here. So isolator will isolate the load from the gate. It will allow the signal in one direction from generator to load, but load to generator, there is no back power, right? And if suppose we are having the variable load, again there is no reflection, and that's why we are having the stable frequency at this point. For frequency stability of generator, we are connecting isolator. That will be the question. Frequency stability. Okay, this is called isolator. Now, second is second device is what? Gyrator. It will provide 180-degree phase shift. It will provide 180-degree phase shift here when the signal travels from this point to this point. When the signal travels from port 1 to port 2, it will provide 180-degree phase shift. That's why it is represented by pi. When the signal travels from port 2 to port 1, it will provide 0-degree phase shift. Port 2 to port 1, 0-degree phase shift. Port 1 to port 2, it will provide 180-degree phase shift. That is the purpose of gyrator, guys. Okay. Then third one is what? Circulator. Circulator we are using. This is the circulator. It is a 3-port device, 4-port device. Okay. Now here we are having the different ports. Okay. This is the circulator. So when we are giving the input, we are getting output from the consecutive port only. We are getting output from the second port only in one direction. It may be the clockwise direction or it may be what? Anti-clockwise direction. We are not getting output from this port. If we are giving input to this port, we are getting output from this port only. When we are giving the input to this port, we are getting output from this port only in one direction only, guys. In other direction, what will be the power? 0. And there is no reflected power. All the ports are perfectly matched because it is a non-reciprocal device. S11, S22, S33 are 0. But when this is the output port, input port, normally we are using the SOI, output input. So S21 is 1. When we are giving the input to 1, we are getting the output from the 2. But what is the opposite? S12 is 0, non-reciprocal device. Non-reciprocal device. When we are giving the 2, 1 will become 0. Similarly, S32 is 1. When we are giving input to 2, we are getting output from 3. But opposite is not true. We are giving input to 3, nothing from the 1. Similarly, what is the S13? Is 1. Output, input. What is the S31? 0. Similarly, you can write S matrix for anti-clockwise direction. If this is in anti-clockwise direction, this is represented like this. So what is this? 1, 2, 3. Then S12 is 1. What is the S21? 0. And so on. You can write all the matrix. And all this is the only the 3 parameters are 1, all other are 0. It is a square matrix 3 cross 3, but it is a non-reciprocal device. Non-reciprocal device. So they will ask, what are the S matrix for what gyrator? What are the S matrix for isolator? So already I have given. So already only one element in gyrator is one isolator. We are getting the signal when we are giving the P, we are getting the P output here. So what is the relation between 2 and 1? 1. But opposite is not true. Isolated port in opposite direction. Only this is 1, all other are 0. This is 1, all other are 0. S11 0, S12 0, S21 is 1, S22 is 0. 1, this is 1 only. This is 1 only. Okay. Similarly, here you will get the -1. In this direction, -1, S21 is -1. I am taking the S output input. Normally we are giving the output and input. S21 is 1, -1. And what is the S12? +1. It will allow the signal but with 0 phase shift, +1. In this way you can write the S matrix. S11, S22 is equal to 0. This is the circulator. It is of 2 port, 3 port, 3 port, 4 port device circulator. But it will allow the current in one direction only. Remember this. Okay. Now, that is the clear. The main purpose of inserting a microwave isolator in microwave circuit, offering minimum forward impedance, offering maximum power output from the source, maintaining the frequency stability of the source, maintaining amplitude stability of the output power. So these are the purpose. That is not the objective question. That is the all are the important points here. Okay. Then, so this is a match the least one with the least two. Select the correct answer using the codes given below. Ferrite device, that is called ferrite circulator, guys. Ferrite device means ferrite circulator. E-plane T, velocity modulation and reflex klystron, guys. So we are for this type of questions, we have to get the idea about the reflex klystron and velocity modulation. What is this E-plane T and what is E-plane T? I have explained. Ferrite circulator I have explained, right? So but we are using all these in what? Amplifier and oscillator. So I will arrange extra session for this. If you have the basic idea, then try to solve this question. Otherwise, I will arrange extra session for this, guys. Now, one more important device, that is called what? Rat race junction. Last one. Rat race junction. This word is now very famous. What is the rat race today? What is the current affairs related to that? Uttarakhand. Hai? Now, what is the rat race junction? It is actually a 4-port device. Right. Here we are having the 4 ports like this. Second one. Okay. Third one. and fourth one. So all are four one side. Okay, just I will give you the easy diagram. Now watch this. Okay, then when we are giving the signal to port 1, you are getting the output from consecutive ports only. Suppose I am giving the power here, then you are getting the output from this, half output from this and half output from this. And then what is the output from the port 3? 0. Means port 1 and 3 are what? Isolated. Yes, red minors are here. Yes, Amitabh, you have given the right answer. When we are giving the port 1, input to the port 1, we are getting the output from consecutive port in both the direction, P1 and P2. But what is, this is not a ferrite devices. Ferrite devices are 3 only. This is just a rat race junction. So when 1, similarly when we are giving the 2, we are getting the output from 1 and 3, not from 4. 3, 2 and 4, not from 1. 4, 1 and 3, not from 2. So simple. Input. So what about the outputs? Output from, if that is given to the 1, you are getting the output from 2 and 4. Nothing from 3. If the input is given to port 2, 1 and 3. Nothing from what? 4. If the input is given to port 3, 2 and 4. And the fourth one, if the input is given to fourth, then you are getting the output from 1 and 3. 1 and 3. All are isolated port. Now tell me, is it clear? Rat race junction. So rat race junction, because it is a 4-port device, it is a reciprocal device. Reciprocal device means S13, for example, if the 2 means 2 and 4 are isolated. 2 and 4 are isolated means S24 is equal to S42 is equal to 0. 2 and 4 are isolated. Similarly, what is the 1 and 3 are isolated? 1 and 3 are isolated. And what about the remaining? S11 is equal to S22 is equal to S33 is equal to S44 is equal to 0. Magic T, just like a magic T, all the 4 ports are perfectly matched. So that is the rat race junction. Now I want that you should write the answer in comments box. You will get the idea. What is the circumference of this rat race junction in terms of lambda g? That is called waveguide. So what is the circumference? Complete. When we are moving from this point to this point, what is the circumference of this? Because there is a distance between these two. There is a distance between these two. There is a distance between these two. And that is the distance between these ports. So what is that distance? So this is the complete circumference is given by x times of lambda g. So what is the value of the x you have to find, and that will be the question, guys. In next class I will try to explain this, why that should be the circumference. There should be the proper addition of the signal and proper cancellation of the signal, guys. So these all the parameters are 0. In this way you can write the matrix for this. Okay, then they will ask some questions on in next session. I will try to cover this. Watch this. What are the limitations of the conventional tube at microwave frequencies? Then what is the two cavity klystron? Microwave tubes like what? Backward wave oscillator, traveling wave tube, magnetron, cyclotron. And what is the function of the magnetron? Why it should work in pi mode? Why the pi mode is the dominant mode? What is the meaning of the pi mode? Why it has the even number of cavities? I am giving you the answer. Even number of cavities, it works in pi mode. Pi mode is the dominant mode. What is the strapping here? What is the meaning of the strapping? This is the strapping. Why we are doing the strapping in magnetron? Just to avoid the mode jumping. But what are the problems related to what is strapping? Then we are using the rising sun structure, just rising sun structure to avoid what problems of strapping. That is the problem of strapping is what? Mode jumping and so on. This is the rising sun structure we are using, rising sun magnetron. Similarly, solid state device, tunnel diode, MOSFET, gun diode. Gun diode works on what? Ridley-Watkins-Hillsum theory, RWH theory, Ridley-Watkins-Hillsum theory, that is called two valley theory, upper valley and lower valley. It has what? Just like a tunnel diode, it has negative resistance characteristics. Negative resistance characteristics, but there is no junction. In tunnel diode, we are having the junction, PN diode. In gun diode, this is a gallium arsenide, indium phosphide, cadmium telluride material. But there is no junction. So that is called solid state device. Another solid state device already I have shown, impact trapet and Barrett diode, guys. Impact trapet and Barrett diode, and we have number of questions on that. Hope you have enjoyed the session. You can also give the mock test on BYJU'S exam prep for ISRO also. First of all, install the BYJU'S exam prep app and start giving the mock test for ISRO examination. And that is the leaderboard, number of participants. Second thing, what is your rank? You will get the idea about your weakness as well as what your strength, guys. So you can start giving the mock test. First of all, install BYJU'S exam prep app. And we have started this course. Crash course is running. You can join, or if you want to start your preparation for 2025 and 2026. Live classes, recorded lectures, study material, practice quizzes and mock tests. And for more detail, you can call at this number. And you can book your free counseling also. I will upload the PDF, this PDF on my Telegram channel, that is Electronics by Sanjay Rathi. This is my channel, Electronics by Sanjay Rathi. Please join that so that you will get the PDF of this session. Okay. So please revise it because we have limited time. On 17th we have exam. To get the, if you have zero idea about the microwave, then get the brief idea about that. Okay. So it will help you. It will boost your confidence. Okay, then thank you very much for attending the session. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel. Have a nice day. Thank you.